Okay, in this video, we're going to discuss solving quadratic equations by factoring. Okay, so first, let's start with the idea of zero product property. Okay, so the zero product property states that if a and b are real numbers, okay, suppose a and b are real numbers, okay, a times b equals 0, okay, so the two numbers a and b equals to 0 if a equals 0 or b equals 0. So later on, we're going to use this property to actually solve quadratic equations by factoring. So let's start with our first example. Suppose we have here, number 1, 2x squared minus 3x equals 0. So the very first step in factorization is to find the common monomial factor between the two terms. So the common is x. So we say x equals 2x minus 3 equals 0. So a while ago we talked about zero product property. So it seems that this one is a and this one is b. So a is x, then b is the 2x minus 3. So what this the zero product property says? It says that if the product is 0, 1 must be 0. So you can say that x must be 0, or the other one must be 0, which is the b, which is the 2x minus 3 is 0. Okay, so here we have already one value for x. So that is our first solution of this equation. Okay, and here we are going to solve for the next value of x. So this becomes 2x equals 3. Then, okay, so the solution of this equation is 0 and 3 over 2. So that's it. Let's proceed with the next one. Number 2. Suppose we have 5x squared minus 10x equals 0. So it has only two terms. The common term between these two terms is 5x. So the remaining factor will become x minus 2 equals 0. So by zero product property, it's either 5x equals 0 or x minus 2 equals 0. So here x equals 0 and here x equals 2. The solution of this is x equals 0 and negative 2. Number 3, suppose we have trinomials. Okay, we have trinomials x squared minus, let us say, 2x minus 15 0. So when we factor trinomials, usually we have quadratic trinomials, especially general quadratic trinomials. In your grade 8, it looks like that. So now, let us try to recall how to factor this x squared minus 2x minus 15. We can use we call it multiplication frame here. So here is the first term, which is x squared, and here is negative 15. So what we do is we split x squared into x times x. Okay, then we try to find the factors of negative 15 that will best fit our as the partner for x and the other x. So we know that 15, we can say that this one is 15 times negative 1, negative 15 times 1, negative 3 times 5, negative 5 times 3. Okay, so let's try to choose one. Let's start with negative 5 and 3. Okay, so we can put negative 5 here, and we can put negative 3 here. Then let's try to do the multiplication table. So we have negative 5 and x gives us negative 5x. Okay, sorry, this should be negative positive 3. Okay, then after that we have x and 3. We're going to multiply that, we'll get positive 3x. Then if we're going to combine the expressions inside the x squared, so that becomes x squared minus 5x plus 3x and minus 15. This becomes, as you can see, this becomes minus 2x. Okay, if the result in this middle term is the same with this here, therefore the factors are correct. Okay, if the result in this middle term is not the same with our given, therefore we need to choose again from here, or from here, or simply we can just switch the signs. We can just say positive 5 or negative 3, then try to see. Then if 3 and 5 do not work for this, we'll proceed with negative 15 and 1 and negative and 15 and negative 1 until we get our middle term. Okay, so since we get our at the very first try we get our middle term, which is negative 2x, we now have our factors. So how do we get the factors? So this is simply a review of factoring general quadratic trinomials. So these are our factors. So we can write it x minus 5, and this one we can write it as x plus 3. So let's erase first, so we can continue with our solving of the quadratic equation. So as you can see, x minus 5 by zero product property that I discussed a while ago. Imagine in layman's term, the zero product property says if you have two real numbers, and when you multiply these real numbers and the result is 0, the product is 0, it's either one of these real numbers or one of these numbers is 0, or it could be that these two numbers are actually 0, both equal to 0, and their product becomes 0. So that is why in this by zero product property, this is our A. Sorry. This is our A, and this is our B. So in zero product property, A times B equals 0. If A times B equals 0, then A is equals to 0 or b equals to 0. So this one becomes x minus 5 equals 0 or x plus 3 equals 0. So that gives us x equals 5, x equals negative 3. That gives us the solution for this equation, which is x equals 5 and negative 3. So let's give another example for factorization with that factoring using the multiplication frame, number 4. Okay, so let us say we have 2x squared minus, let us say, plus 7x plus 5 equals 0. So let's try to, we can do that as this. Okay, then let's try to use the frame. So we have 2x squared and 5. So since that is positive 5, the 2x squared, we can now split it into 2x times x. Okay, so now the danger here, the tricky part here, because 2x now is different from x. Not like our example number 3 a while ago, the x squared is split into the same factor, which is x and x. So the switching of the factors here doesn't matter. Okay, but here, since 2x is now different from x, switching of the factors matters already. So let's try 5. 5 is 5 times 1, and it can be negative 5 times negative 1. Okay, but most likely we are not going to use negative 5 and negative 1, because looking at our given, all are positive terms. Okay, all are positive terms. That makes it sensible to use only 5 and 1. But we are not sure which one is 5. Is it the partner of 2x, or is it the partner of x? So let's try. So this is 5 here and this is 1 here. Let's try. Or let's try first. I think it's what happened? Let me just repeat. Number 4, 2x squared plus 7x plus 5 equals 0, and we try 2x squared and 5. This is 2x and this is x. We try 1 and 5 here. Okay, so let's try to multiply this portion. 1 and x gives us 1x. 2x and 5x gives us 10x. As you can see, this portion, if you're going to combine it, similar terms, 10x and 1, it gives you 11x, which is very far from your middle term, which is 7x. So we try to switch. Okay, we try to switch. Okay, a while ago we used 1 on top, 5 on the side. Now we'll use 5 on top, 1 on the side. Then if you're going to multiply this and that gives us 5x. And 2x and 1, that gives us 2x. As you can see, if we're going to combine 2x and 5x, that gives you 7x. So that's in turn our factors factors for this one. So our factors are 2x plus 5, x plus 1. So again, using the zero product property, 2x plus 5 becomes 0, or x plus 1 becomes 0. Solving for x, we'll get 2x is just negative 5, therefore x is just negative 5 over 2. Negative 1 equals 0, therefore x is just negative 1. That gives us the solution for this as x equals negative 5 over 2, negative 1. Okay. So now let's provide one more example, two more examples actually, using different methods of factorization or factoring. Number 5. Suppose we have y square minus y minus 20 equals 0. Okay. So again, this is a general quadratic trinomial, so you can factor it like this way. We can use this one. So on top are the factors of y square, below are the factors of negative 20. Okay, so if we're going to factor y square, that is simply y times y, and negative 20, there's quite a lot. So negative 20, that is negative 20 times 1, 20 times negative 1, negative 10 times 2, 10 times negative 2, 4 times negative 5, negative 4 times positive 5. So sometimes to choose from this list of factors, intuition helps us. Okay, the common sense. Okay, let's try with negative 4 and 5. Let's try with negative 4 and 5. So negative 4 here, then positive 5 here. So what we're going to do is to cross multiply. Okay, let's cross multiply this one. Y times 5, that is eventually 5y. Then cross multiply this one, that is eventually negative 4y. So if you're going to combine this one, this is positive y. But our target, our middle term is negative y. So what we do? This means that they only differ in sign. So we need to switch. Okay? We need to switch the sign. This becomes positive and this becomes negative. Okay? So cross multiply again, y times negative 5, that is negative 5y. Let me just highlight it again, negative 5y. Then 4 times y is positive 4y. So negative 5y and positive 4y, that gives you negative y. Okay? So that means our factors now are correct. But in this case, how do we write the factors? Okay, how is it cross? So we write the factors as vertical. So just emphasize it. We write our factors as like this. That's y minus 5. And we write the factors like this. That's y plus 4. Okay. So let us erase the others. So solving again, y minus 5 is 0 by zero product property, or y plus 4 equals 0. So y minus 5 equals 0, that is basically y equals 5, y plus 4 equals 0, that is basically y negative 4. Then this gives us our values for y, solutions for this quadratic equation. Negative 4, 5. Okay, for our last example, we have 6 here. Let us say 3y, 3p square, okay, 3p square minus 3p square minus 11p minus plus 6 equals 0. Okay. 3p square minus 11p plus 6 equals 0. So let's try. This becomes like this, as it is a general trinomial. So we have to, okay, again, on top are the factors of 3p square, below are the factors of positive 6. Okay, so 3p square is basically 3p times p. And positive 6, mind you, positive 6 gives us two factors, two set of factors. No, it's 4. 6, 1, negative 6 and negative 1, negative 2 and negative 3, 2 and 3. Okay, so if you're going to put 6, 1 here, look at this. I said a while ago that we can use our intuition. If we're going to put 6 here, positive 6 and positive 1, it is very unlikely that we'll get negative 11. You see that? Positive 6 and negative 1, it will give us really not that negative 11, because when you cross multiply, it will give us positive. So let's try with the negative. Negative 6 and negative 1. So let's try with this one. So we have cross multiply 3p and negative 1. So let me just highlight this one, so that becomes negative 3p. Then this becomes negative 6p. Both are negative. That gives us negative 9p, which is our target is 11p. So this will not work. This doesn't work. Positive 2 and 3 will not work as well. Why? Because it's positive and we have a target of negative 11p. So maybe it's really negative 2 or negative 3, only that which one is negative 2? Is it here or here? If that doesn't work, let's switch. Negative 3 here, then negative 2 here. We can switch if that doesn't work. So let's erase first. Let's erase first. Good idea. Okay, so negative 2 and negative 3. So negative 2. So you can use your intuition, the basic mental math, to think over. Okay, not really one by one trial and error, but mix it with intuition. Negative 2 and negative 3. Okay, so cross multiply. We're going to cross multiply this. That becomes negative 2p. Cross multiply this. That becomes negative 9p. Oh, this one works. Negative 11p. Okay, so it's different if we're going to switch. If we're going to switch and this becomes negative 3 and this becomes negative 2. So negative 3p and negative 6p. And that is negative 9p, which is different from negative 11p. So negative 3p and negative 2 are correct. That gives us our factors. This one. So like we can write it here. P minus, let's write it again in blue. P minus 3. And this one again. 3p minus 2. Okay, since we are done factoring, we can just erase this. Okay, we're just reviewing the factoring in your previous years, and because some were not able to master factorization. Okay, anyway, there are a lot of methods in factorization depending on the case given algebraic expression. So by zero product property, this becomes p minus 3, 0, or this one becomes 0. So here p is just 3. That is our first solution. Here we need to get to add to both sides. That's the rule in equation. Whatever you do on the left side, you must do on the other side of the equation. It's like balance scale. So this becomes, the negative 2 and positive 2 become 0. So we are left on the left side with 3p. And the other side, 0 plus 2 is 2. Okay. So 3p, all 3p's, they are all sharing 2 units. Therefore, each p will have 2/3. That is our solution for this.
Ay, nigara! Uy!